Okay, we're going to look at solution dilutions. And we've already looked at this in class. This is a mini review for you. So we have the concentration times a volume, which gives us the number of moles. So we're going to look at a high concentration and a low concentration compared with a low volume and a high volume, or vice versa, to get the diluted solution with respect to its concentration, or the concentrated solution with respect to its concentration. So in class, we looked at this formula of molarity 1 times volume 1 is equal to molarity 2 times volume 2. Now, I thought about this, and there is a better way to express it. So let's say we want to be a little bit more explicit than 1 and 2. Let's say we want to call this the molarity of the concentrated solution times the volume of the concentrated solution equals the molarity of the dilute solution times the volume of the dilute solution. Okay, so that's another way of representing M1V1 equals M2V2. Now, the problem asks, what volume of a 6 molar sodium chloride solution must be used to make 0.80 liters of a 0.15 molar sodium chloride solution? So it's easier to look at this with respect to concentrated and dilute. So if you notice, 6 molar compared to 0.15 molar, that gives us the two concentrations, and 6.0 molar is greater than 0.15 molar. So we would say this is our concentrated and this is our dilute. Okay? Now, the next thing we want to do is we want to see which volume goes with what. So the question asks what volume of a 6 molar solution must be used to make a 0.8 liter of 0.15 molar. So we're making 0.8 liters of the dilute solution. Okay, we're making that volume of the dilute solution. So let's come here and let's write out what we know. We have the molarity of the concentrated is equal to 6.0 molar. The volume of the concentrated, so that is unknown. We don't know that. Now, the molarity of the dilute solution is equal to 0.15 molar, and the volume of the dilute solution is equal to 0.80 liters. So we know this is the dilute solution because what? Our volume has increased, so we have more volume than the concentrated solution. Well, we will know that we have more volume than the concentrated solution. So let's set this up. And say that M of the concentrated times volume the concentrated is equal to M of the dilute times the volume of the dilute. So let's plug in our numbers. 6.0 molar times the volume of the concentrate, we don't know, is equal to 0.15 molar, capital M, moles per liter, times 0.80 liters. So when we solve for the volume of the concentrate, we have what? We just want to divide both sides by 6.0 molar, and we will have 0.15 molar times 0.80 liters divided by 6.0 molar. Our molarities cancel, leaving us with the unit of liters. And when you do that multiplication and division, you get 0.20 liters. You will get 0.20 liters. And that is your volume of the concentrate. So you have 0.20 liters. So notice that we have increased the volume of this, and we've made a dilute solution. At this molarity. Okay? So that was pretty easy. Let's try this problem. It asks, to what volume in milliliters should you dilute 100 milliliters of a 5.00, and this should be molar, calcium chloride solution to obtain a 0.750 molar calcium chloride solution. So let's write our equation out. And remember, this should be 5. There we go. So let's write our equation out, where molarity of the concentrate times the volume of the concentrate is equal to the molarity of the dilute times the volume of the dilute. Now it says, what volume in milliliters should you dilute 100 milliliters? So we have a 5 molar solution of calcium chloride. So our molarity of the concentrate is equal to 5.00 molar. Now, our volume of the concentrate, it tells us to what volume should you dilute 100 milliliters. So the volume of the concentrate is equal to 100 milliliters, but this milliliter must be changed to liters. To work these dilution problems, we must change to use this formula, and this is the same as M1V1 equals M2V2. These two are the same. To use that formula, M of the concentrate is equal, M of the concentrate times the volume of the concentrate is equal to M of the dilute times the volume of the dilute. We must change this to liters. So what do? We remember from converting that 1 milliliter is equal to 10 to the minus 3 liters. And that is going to give us 0.1 liter. So that is the volume of the concentrate in liters. So now the molarity of the dilute is equal to 0.750 molar. You see, this is a higher concentration than this. That's why it's considered to be the dilute. And the volume of the dilute is equal to what? We don't know. So we can come over here and we can plug in our values that we have. So I'll write this out again. M, the concentrate times the volume. Concentrate is equal to molarity of the dilute times the volume of the dilute. And we can say that we have 5.00 molar times 0.1 liter is equal to 0.750 molar times what we're looking for, the volume of the dilute. Okay, so when we do our algebraic manipulation, we have the volume of the dilute is equal to 5.00 molar times 0.1 liter divided by 0.750 molar, and that is equal to what? Our units of molarity cancel out, and we should be left with something in liters. So that is equal to 0.667 liters. Now, the question asks what volume in milliliters. So now we must take this volume in liters and convert it to milliliters. So we have 0.667 milliliters times 1 milliliter is 10 . So write this correct. 0.667 liters, so that must be changed to milliliters. So we have 1 milliliter. Our conversion factor is 10 to the minus 3 liters. Liters and liters cancel. So when we do that multiplication or division, either one you want to call it, we get 667 milliliters. And that is the volume of the dilute in milliliters. Okay. Now, let's look at this last problem. So, go through it very detailed. So what was our formula? The molarity of the concentrate times the volume of the concentrate equals the molarity of the dilute times the volume of the dilute. And that's the same thing we have in our book, that M1 V1 equals M2 V2. Now I write it this way so we can see and better put labels on them and identify it as concentrate and dilute in the problem. So look and compare what we have. We have a 6 molar solution and a 1.2 molar solution. So M of the concentrated solution is 6.00 molar. Okay, but it says what volume of that. So what volume of the concentrate we don't know. Okay, so now the molarity of the dilute is equal to 1.20 molar. The volume of the dilute is equal to 0.525 liters. Okay, so plugging this in to this equation, the concentrated times the volume, the concentrated is equal to M of the dilute times the volume of the dilute, and that is, let's put our values in. We have 6.00 molar times the volume of the concentrate that we don't know is equal to 1.20 molar times the volume of the dilute, 0.525 liters. Okay, so when we solve for the volume of the concentrate, we have 1.20 molar times 0.525 liters divided by 6.00 molar. Our molarities cancel, leaving us with the unit of liters that we should have. And that is equal to a volume of 0.105 liters. All right, so that is the volume of the concentrated solution. Now, for homework, and this is part 4 of chapter 1. Excuse me, part 4, chapter 4, homework. I want you to do number 61 through number 64, and that is on page 188 in the back of the book.